Welcome all of you for video 2 introduction of that power semiconductor device. So in this video we're going to see about depth in power semiconductor device. Actually in unit number 1 behind about the introduction of the power semiconductor device, this is a slide. This video it will going to explain you why do you want to study power electronics. Because the introduction of that is a power semiconductor device, you should be very clearly know for that with respect to the your conversion, with respect to the conversions. Okay, the slide it is showing for that is symbol of power semiconductor device. You can say about that power semiconductor, it will going to start with a diode, SCR, MOSFET, IGBT, GTO, etc. When you have totally segregated into the two part, means one is a uncontrolled device, second one is a controlled device. Uncontrolled device means it is an example for that one is a diode. It doesn't have any gate signals. But remaining devices, when you have see here in the slide is showing all the remaining devices a controlled device. Why it is called as a controlled device means it has that a gate terminal, gate or base terminal is there. Okay, what is the purpose of the gate and base terminal? It is a controlling pulses. When you will going to give the pulse to that one, then only the switch is on and off. So when you will going to give the power from anode to, you want to pass the power from anode to cathode. Okay, if you are not apply the gate pulses, the power is not flow from anode to cathode. So the gate terminal helps to, you will going to turn on the devices. The gate terminal is used to, you will going to turn on the devices. That's why it is a controlled device. That's why it is called as a controlled device. Okay, detailed I will going to tell about that one few in the forthcoming of the slides. So you have just look it. So this is the thyristor symbol, this is a BJT symbol about that one. What are the terminals also you should be know very clearly about that one. So as a students, you should not make the mistake to draw the symbol of the diagrams. So symbol of the SCR, this is symbol of the SCR. So anode, cathode, gate. The gate terminal will come to the near to the cathode. Okay, you should not draw near to the anode. Why gate terminal is drawn near to the cathode? So with respect to the constructions, the gate is coming very close to the cathode. That's why the symbol is draw cathode. Cathode is near to that cathode. So gate is near to that cathode terminals. So next one you have see that bipolar junction transistor. The transistor it consists of that one base, collector, emitter. There are three terminal: base, collector, emitter. So in that electronics device, you may study about that BJT classification, N type of BJT, P type of the BJT like. So next one you have coming to that MOSFET, metal oxide field effect transistor. Actually the transistor, power transistor, it will going to come under the MOSFET and IGBT. So it consists of that three terminals: drain, source and gate terminal. Drain, source and gate terminals. The next one IGBT. How the IGBT is coming? You have look the symbols of IGBT. Okay, it consists of that three terminals: gate, collector, emitter. Gate, collector, emitter. How it is coming? Gate, collector, emitter. Why it is coming means the IGBT is nothing but the combination of BJT and the MOSFET. The IGBT is nothing but a combination of the BJT and the MOSFET. How it is combination? What is there in that one? So here base, collector, emitter. Here gate, drain and source. So left hand side is a gate you can take. Yes. Right hand side of that collector and emitter. This is the right hand side. The same thing you will going to take. Okay, the symbols also you will going to say take. Left hand side, what about the gate symbol you can say. So you will going to combination of MOSFET and IGBT is called MOSFET and BJT is called IGBT. So that should be very clearly you have know, and you will going to write about that one is what is IGBT. So IGBT is a combination of that BJT and MOSFET. Okay, then next one more device you will going to see about that GTO. What is that GTO? Gate turn off thyristor. Actually it is coming under the thyristor family. This is a SCR, silicon controlled rectifier, or another name is called thyristors. It has that three terminal anode, cathode, gate. It is also same three terminal anode, cathode and gate. So when you have see that gate of that line, it doesn't have that any you mean any arrow mark. Here you can see that one, there are two arrow mark is mentioned. One is going inside, another one is coming outside. So what is the meaning of that one? You have the possibilities, you will going to apply the current to that this direction as well as this directions. So it is helps to you can on and off of the GTO. That's all. So you have see that once, let's you have proceed further. Okay, you have see, so I have draw for that diode. What is a diode? It is a unidirectional device. Unidirectional, only power is flow from that anode to cathode, not cathode to anodes. So this is a one-way directions. So like you are going to see about the door. Okay, the door, it will going to operate on that one-way directions. It will going to open for that one way. You can't to push on that another direction where it is not that type of the door, one way direction of the door. So like about that, this is a diode. Okay, uncontrolled device. Why it is called uncontrolled device? Uncontrolled means it doesn't have any gate terminal. It doesn't have any gate terminal. That's why it is called as an uncontrolled device. The next one is see about that one is a controlled device. This is a SCR is showing, this is a GTO is showing. What is the difference? There are two arrow mark is mentioned. So where is a plus is there in anode side, minus is there in cathode side. Okay, like about that one, this device is a developed. Okay, this is about that one. Okay, so uncontrolled device and the controlled device of that thyristor and GTO. So what is the difference between thyristor and GTO? Thyristor is a controlled on and uncontrolled off. So you will going to see detailedly why it is uncontrolled off in that one. In that you will going to see about thyristors. This video it will going to tell about that introduction about the power semiconductor devices. So we'll go ahead on that one. GTO. So you have see there are the two arrow mark is mentioned, controlled on and controlled off. The next one you have see about that MOSFET and IGBT. Okay, voltage controlled devices. What about voltage controlled devices? Here is a gate and a drain and a source. So you will going to ask me question, why it is called voltage controlled device, why that one is called a current controlled device. So when you will going to ask that questions at the end of the static and dynamic characteristics. So static characteristics of the devices, when you will going to complete the static characteristics of the devices, automatically you are coming to know that one, why it is called as a voltage controlled device, why it is called as a current controlled device. Okay, the static characteristics. What is the static characteristics? It's nothing but the testing of that device. You will going to conduct a testing and draw the characteristics curve. You will going to draw the VI characteristics of the curve. That is called the static characteristics. Dynamic characteristics, nothing but the switching characteristics. How it will go to on and off. Okay, what is the time period, limit, what is the rising time, what is the falling time, what is the settling time. That is called dynamic characteristics of the switching. Coming to here, so already I explained about that MOSFET and this is a MOSFET, drain, source and gate, collector, emitter, BJT and the MOSFET combination is developed is called, what is that one? IGBT. The next one we will going to see about that some passive element, high frequency transformer. In video 1 I explained about what is the purpose of high frequency transformer. It is used in that one and high frequency devices. So high frequency transformer also we are going to using. The transformer is now, you know that one in electrical machines you studied about, transformer is not operate on that DC power supply. So here you will go to electronics devices, you will going to use for the high frequency transformer. What is the purpose of your using the high frequency transformer? Means you will going to reduce the space of the devices, reduce the space of the board. For example, in olden days you have seen that one CPU it is occupy on that one room size. Now it is reduced into that one notebook size. How it is reduced? For example, one more example I will tell you. So mobile phone, in olden days the mobile phone, the size is starting the condition, the mobile phone size is very big. Now that one is mobile phone is coming under the very small, okay, it is there in a touch screen button type, very small size. How it is there? It is a device is changed, the device power consumption is changed. They are using the SMD device. SMD device means, okay, surface mount device. So like they are using on that ones, okay. So the small size and lightweight when you are going for the high frequency of a transformer, when you will going to use on that ones. So you will going to make that in power electronics, you will going to design the inductance and the capacitance. What is the capacitance do I want to use? So use the formula to substitute them to ones, okay, and you will going to find out for that what is the capacitance of capacitance and what is inductance. The next one, so different types of the relay switches. So you, okay, switches you have already know. So switch, it is used to on and off of the appliances, on and off of the appliances. Okay, for example, single pole single throw switch. So single pole single throw switch, it is used. Another one is a single pole double throw switches. Okay, double throw switches, it is used. Single pole double throw. Another one is a DPST, double pole single throw, double pole single throw. Okay, double pole double throw switches. So like the switches, it is going to classify. Okay, deep type of switches, relay switches, like that switch, it will going to classified. So okay, so in that power electronics, you will going to use for that switch also. The switch, it is a reset switch, you will going to reset operations you can use. Another one is for even higher ratings appliances. Higher rating appliances means AC appliances, AC 230 voltage, you will going to operate it, you will going to use for that relay switches. Relay switch, it will going to use to on and off of the appliances, on and off of the appliances. So for remote, it is used to, you will going to control the appliances, control the AC on and off. So how it is possible? Remote, it is used to, okay, you will going to turn on the AC and turn off of the AC, turn on the AC and turn off of the AC. How it is working? The relay is on and off. Okay, so we go for the classification of the power semiconductor devices. So first one, basically one type you can say two terminal devices, three terminal devices. Two terminal devices, three terminal device. Two terminal device means that is called a diode. So it is called a diode, you can say about. Next one is a three terminal devices, means you can come under the thyristor, BJT, MOSFET, IGBT, like it is a three terminal devices. So next further, so minority carrier devices. PN diode is a minority carrier. So these three, it is showing as a majority carrier device and minority carrier device, BJT, thyristors and IGBT. So it will going to classify majority carrier device, minority carrier device, majority carrier device, minority carrier device. So we will going to see about that current control devices. So current control devices, what is thyristor and IGBT? Okay, you have to keep in your mind, it is a minority carrier. And one more device you can keep it, IGBT also come under this ones. So majority carrier device means, what about that ones? So MOSFET, FET, JFET, you will going to say about that majority carrier devices. So two terminal and three terminal devices wise, it will going to classify. Then next one, okay, further it is a classification is said about detailing. So you should be very clearly, why do you want to know about this concept? This is a power electronics background. When you will going to attend for the Viva question as well as interview, technical interview, they will going to start to ask this fundamental of the questions. So what is, you can say is, tell me the application or tell me the example of the uncontrolled on and uncontrolled off of the device, means you can say about that power power diode, you can say controlled on and uncontrolled off. Controlled on and uncontrolled off means thyristor, you can say about that thyristor. Next one is, you can say about the controlled on and controlled off, BJT, MOSFET, FET, IGBT, like you can say about that ones. So like it is a controlling base, it is going to classify. So next one is a continuous gate signal requirements. So when you will going to apply for the continuous of the gate signals, so I will going to apply the, if you are not apply the gate signal in continuous, okay, the device is not operated. So BJT, MOSFET, IGBT, these are the devices needed for the continuous of the gate signals. So next one is a gate pulse pulse gate requirement. What is a gate pulse requirement? At a starting times, At a starting time, it's a gate pulse is requirement. Gate pulse requirement at a starting times. So at the initiating time, we will going to apply that a gate pulse, SCR and GTO. So SCR and GTO. So it is a minimum current required to turn on the devices. So once it is crossed the minimum current, even you will go to cut the gate pulse. Even you will going to cut the gate pulse. Even this is a you will going to cut the gate pulse. The device it is a keep on turn on. The device is keep on turn on. SCR and GTO, these two minimum current is required to turn on the device. So minimum current, what is the minimum current? Okay, that is called the latching current. So minimum current, okay, required to turn on the device. Latching current. Holding current means it is minimum current below. When it is crossed, it is automatically thyristor is turn off. That is called the holding current. So natural turn off of the device. SCR is a natural turn off of the device. So pulse gate requirements. So you will going to apply that minimum current to turn on the SCR and GTO. Okay, it is a next you can say about the bipolar voltage withstand capabilities. It is a bipolar voltage withstand capabilities. So it has the capability to withstand under the bipolar. Unipolar voltage withstand capabilities you can say about that remaining BJT. So BJT, MOSFET, GTO is coming under that one, both unipolar as well as bipolar it will going to come. So next one is bidirectional current capabilities, triac. What is the bidirectional current capabilities? So anti-parallelly two thyristor is connected, means anti-parallelly means opposite. So that is called a triac. When you have see the symbols, okay, automatically you will going to coming to know that one how anti-parallelly connected on that one. Bidirectional current capabilities, not voltage capabilities, current capabilities. So next unidirectional current capabilities. Remaining device all are the unidirectional current capabilities. So triac only bidirectional current capabilities. Like that one is this power semiconductor device is classified. Okay, so this classification further review they will going to say about that okay, uncontrolled device. What is uncontrolled device? Diode. Okay, two terminal. Okay, anode and cathode. Half controlled device, fully controlled device. What is half controlled device? Controlled on, uncontrolled off. Controlled on, uncontrolled off. SCR you can say about that one. Fully controlled device, what is then? Controlled on and controlled off. Like you can say about MOSFET, IGBT, FET you can say about that one. GTO you can say about that one. So it will going to classified. So this is about okay, what we were discussed. Okay, so once again that other categories, what is it one? Current controlled device, voltage controlled device, it is classified. Pulse triggering device, level triggering devices, like we have discussed. Unipolar, okay, majority carrier device, minority carrier device, okay, composite device, like it will go to classified. And a few of the examples, current controlled device. What about the current controlled device? Thyristor, GTO, voltage controlled devices, so MOSFET, IGBT, okay, and then few more devices also you will going to say about that voltage controlled device. Another one is a pulse triggering circuits, pulse triggering. So it is a minimum current. Once even that one gate pulse, one minimum current is crossed, so you will go to cut down the gate pulse, so it will going to keep on turn on thyristor, GTO. Next one is a level triggering circuits. If you will going to cut on that one gate pulse, okay, or base terminal you will going to cut, means automatically the switch it will going to coming to that off positions. So like it will come to there. Okay, next one is a unipolar devices, majority carrier device, okay, minority carrier device, okay, composite device, like it will going to classify. Okay, so the base terminal or the gate terminals, it is needed for that pulse or triggering. So who will going to give that this pulse or triggering, means that is called controller. It will going to give the pulse or triggering. So like, okay, next slide it is so about the diode classification of the diode, PN junction, fast recovery diode, the Schottky diode, okay, and like it is a classified power transistors, BJT, MOSFET, IGBT, so uni junction transistors, okay, static induction transistor, okay, MOS controlled thyristors, like it will going to classified. So next one is thyristor variety. You have see, just you will going to list out so many varieties of that thyristor. It is starting with the silicon controlled rectifiers, its name itself. So GTO, okay, you can say GTO, triac, okay, like it is coming under this category of that ones. So thyristor varieties. So even that unit further of the videos, you will going to detailedly see about that the thyristor varieties, thyristor operations. Okay. The next one is a symbol of that representation. So already you have seen and a few more symbols. Okay, SCR is a anode, cathode and gate terminals. Diac means what is a diac? Two diode. I will going to use the two diode anti-parallelly connected. Does diode has any gate terminal? No, diode does not any gate terminal. Two diode is connected anti-parallel. That is called as a diac. Okay, two thyristor is connected anti-parallel means that is called a triac. Okay, what about GTO? I will going to connect it only one thyristors, but a gate terminal it has that one. There are two gate terminals, in as well as out. That is a in as well as out. So diode, so anode and cathode. Actually it is here you can see that one cathode available. IGBT means combination of BJT and MOSFET. From the MOSFET left hand side gate, and then right hand side is a what about that collector and emitter. Collector and emitter is there. Then MOSFET, gate, drain, source. Okay, symbols. So we have see about that one, symbols of that ones. Okay, symbol of that power semiconductor device, where it is that triac. You have anti-parallelly. Okay, SCR is there. Okay, N channel IGBT and P channel IGBT. What is the difference N channel and IGBT? The arrow mark inside and then outside. That is the difference. Similarly, N channel MOSFET and P channel MOSFET. What is that one? The arrow mark is going inward direction and outward direction. N BJT and then okay, N type BJT and P type BJT. What is the difference? The arrow mark is going inside and outside. Like that one is a symbol. It will going to differentiate. So next one will coming to that end of that power semiconductor device. Okay, this which is device do I want to select? What is the difference between the one device to another device? So this is we're going to see about the last where end of the topic of that ones. You have see that one thyristors. So there are I have draw the graph x-axis as well as y-axis. What's there in x-axis? Frequency in hertz. So hertz is there, then kilohertz, megahertz. Like that x-axis there, kilohertz, megahertz. What about in y-axis? Power in VA ratings, power. So watt, kilowatt. Another one is megawatt powers. I need to operate for that one. I need to control the conversion in megawatt range. Okay, for transmission line. Okay, HVDC transmission line. So which device do I want to use? Thyristor you can use. So thyristor it has that kilo. It is available from that 100. Okay, 100 watt. It will going to available. It will going to 1 kilowatt. It will going to available 100 kilowatt, 1 megawatt. Okay, 10 megawatt caliber on that thyristor. It is there. Okay, it is a controlled on, uncontrolled off. Suppose I needed to controlled on and controlled off, then you can go for the GTO. So GTO it has that one. Okay, it will going to operate on the 1 megawatt range. It will going to operate it. So what is the limitation? One more. This is a switching frequency. What about switching frequency of the thyristor and GTO? So it is near to that 1 kilohertz. 1 kilohertz only. This is a switching frequency. So thyristor is a lower than that GTO switching frequency. The next one is a switching frequency. I need to increase the switching frequency. Okay, 1 kilohertz to 10 kilohertz range. I want to increase that one means. So next you can go for the IGBT. So IGBT automotive application, robust and welding machines like that motor driver application. You can go for that one. So when you have increased the switching frequency, automatically the power rating is it will going to reduce. It will going to available maximum for that 100 kilowatt it is a power rating, it is available. So power rating is reduced. 100 kilowatt or 10 kilowatt or 1 kilowatt range of application you can use for the IGBT. Okay, this is for that one. It is a frequency is a 1 kilohertz to 10 kilohertz near that ones. I need to increase more frequency, switching frequency I need to increase. So fast switching frequency, so 100 kilohertz I want to increases. So 10 to 100 kilohertz, then you can move to the MOSFET. So if you have moved that one, automatically it is a power rating is reduced. It is applicable for that okay around 1 kilowatt power rating application only you can use. So this diagram is very clearly it is mentioned. Okay, thyristor, IGBT, MOSFET. So it's a frequency wise thyristor, IGBT, MOSFET. Then power wise, what about that one? Higher power you can use for that thyristor, then lower power the IGBT, then lower power MOSFET. So this is the same diagram in a different way it will going to make sense. So you have see about that one. So thyristor is occupied, then after that one is IGBT is occupied, and after that FET or MOSFET it is occupied. Okay, and then where it is coming, GTO is coming here, BJT controlled on and controlled off, you will going to come here BJT, so you are going to use on that one. So a few more applications related to that one. So you have see that one thyristors, so higher power record places, even the frequency is lower, HVDC transmission line, okay, you will going to use on that one. So GTO, so high power as well as some frequency, it will going to increase the frequency, okay, but this is a limited about the frequency. What is that one? Thyristor is limited, so then you will going to use for the GTO. So GTO application, motor control you can use, and the UPS system you will going to use, and the electrical car application you will going to use. The next one you will go for that one, okay, IGBT, and after that MOSFET of the places. So you will going to okay. So MOSFET applications, okay, we will going to power supply for that audio, and then switching power supplies, okay, and then VCR, okay, like it will going to use for that one, microwave oven, okay, air car we will going to operate it, okay. Car means in that lighting systems as well as controlling system, electrical car, when you have go for that one motor controller drivers, so you will go for that this type of the, okay, semiconductor devices. So this is ratings of that appliances. So power plant, what about the ratings? Okay, under the electrical car means what about the rating? It is starting from the 10 kilowatt to that 100 kilowatts. So you want to know about your ratings. So for about previous slide, it is explained about that one, the rating of in that y-axis. So about that power ratings. So power ratings. Okay, high power rating means you can use for that megawatt range means thyristor you can use. Another one is somewhat I want to reduce means power rating reduce. Then you can go for the GTO. Then further I will going to reduce the power. You can go for the IGBT. Further you will going to reduce the power. You will go for the MOSFET. So like you will going to power rating, it will going to classify. That's all. So this is about the power semiconductor device background. So coming to the recap about that this video, the first one is a power semiconductor device. It will going to classify 2 terminal and 3 terminals. Minority. Second one is you can say about the minority device and the majority device. Minority carrier device you can say about current control device BJT and SCR, and one more device IGBT you can say. Another one is majority carrier device you can say about what about that one? FET, MOSFET, you can say about that one. The next one is uncontrolled on and uncontrolled device, and the controlled device, like you can say the classification. Uncontrolled device means the diode, and the controlled device means you can say about that one is SCR, okay, SCR, BJT, MOSFET, IGBT, like you can say about that one. The next one, okay, pulse wise. Okay, pulse triggering, level triggering. What is a pulse triggering? So minimum current only needed for a once turn on purpose. Okay, turn on. So you will going to use for that one is SCR, and then GTO you can say. Okay, level triggering, continuous of that gate pulses is needed. So that is called the BJT, MOSFET, IGBT. Like you can say about current control device, voltage control device, IGBT, MOSFET. You can use, and current control devices here and GTO. So next we'll go into video, you will going to see about that static characteristics, then behind about why it is current control device, why it is voltage control device. That's all. Thank you.